In this example, we've got another, more complicated looking equation here, right? That we're trying to solve for, in this case, theta. So we're told to solve it between 0 to 2 pi, but you might notice because we've got all this kind of stuff happening inside the sine function, we're going to have to do some of that expanded domain stuff, kind of magic. So the easiest way to do it is do it step by step. So basically you want the bit inside your domain that's squished between the two extremes to look like this. So that the way to do that that's easiest is first do the stuff that's done to theta. So in this case, times by 2. So we times both sides by 2. Well, 0 by 2 is just 0. 2 theta is less than 4 pi. Now, to make it really work, we got to add in another pi and 4. So if you think about it, 0 plus pi and 4, that's just pi and 4. So less than or equal to 2 theta plus pi and 4 is less than or equal to 4 pi plus pi on 4. Just move my pens out of the way. Where are we? Pi on 4. And there we have it. We have this, we have our domain expanded, so now we can do our little substitution. I'm just going to use A to represent all of that mess inside in the middle of my domain, and I'm going to solve my new kind of slightly altered equation. Sine of A is equal to -1 for this domain of A, which is a pretty weird domain, right? You're thinking about, well, we're going between pi and 4 is the smallest thing we can look at, all the way up to 4 pi plus pi and 4, which, you can simplify that a bit more. I kind of like to keep it just like this, but 4 lots of that would be 16. So we're really going between 17 pi on 4. Yeah, pi on 4 to 17 pi on 4. But that's probably an easier way to look at it. So let's do it. First of all, let's think about when does sine of A equal -1? Well, there's actually on a unit circle only one time. When it's down here, yeah? It's -1, so the angle is, well, it's right on the y-axis, isn't it? So, you could have, in terms of radians, that would be 3 pi and 2 is a value that would possibly work. But let's just think about all the ones we could have. So, in terms of A, in this domain, so 3 pi and 2, that's within that domain. So we can include that, 3 pi on 2. Next we get around to 2 pi and all the way around again. So if you're going all the way around again, how many have you gone? Well, you've gone 3 pi would be 6 pi and 2, so 7 pi and 2. That is also within this domain here. And then if we were to go around again, it would be something like, 5 pi, wouldn't it? Yep, so wait, 4 pi, 5 pi, that's 10 pi and 2, 11 pi and 2. 11 pi and 2 is bigger than this, so we don't include it here. So now what we got to do is we have to undo our substitution. So we said A was all of this mess. Well, we got to bring the mess back. So we got 2 theta is equal, 2 theta plus pi on 4 plus pi on 4 is equal to all of these things. So we got to do the algebra to everything, yeah? So a bit messy, but 7 pi and 2. So first we go, let's just get rid of that pi and 4. So we got to subtract pi and 4 from both sides. So that would be 6 pi and 4. Take away pi and 4 is 5 pi on 4. And then this would be the equivalent fraction in terms of quarters on the bottom. So what it'd be 14 pi on 4, and we're taking 1 pi and 4 away, so we get 13 pi on 4. And then finally, we just divide everything by 2. So those denominators are going to double. We get 5 pi on 8. And we get 13 pi on 8. So just to kind of recap, if you think about it, this is really just equivalent to what we've been doing. The only thing that's a bit more complicated is that, it's a bit harder to, you got to include this additional bit, and it makes things a bit messier, but it's really the same process, right? The process that we're doing is we're changing our domain to look like what's inside our trig function, and then we're doing this substitution, we're finding the exact values in our new expanded domain, and then we're resubstituting back the messy stuff inside our trig function, and we're solving for the variable we actually wanted to solve for in the first place. And we get our values, and then we are finished.